All right, here we are for the last 2 pages of these notes, guys. And we've got identities, right? So I'm going to start with this left identity with this side because that looks more complicated. I'm going to work to get tangent. And the two that I can make substitutions for are these double angles. So I'm going to start by saying, well, 1 minus cosine 2 theta, that's cosine squared theta minus sine squared theta. And then sine 2 theta is 2 sine theta cos theta. And if I want tangent, I kind of know, all right, I want to have cosine here and I want to just have sine at the top. So I'm going to leave this and try and manipulate just this stuff. Okay? So if I do that, I've got 1 minus cos squared theta plus sine squared theta over 2 sine theta, and then I'm just going to have, you know, the cosine kind of hanging out over here. I don't know if I need to do that. But. All right, well, look at this. Look at this. 1 minus cosine squared, that's sine squared. So sine squared plus sine squared, that's going to equal, I guess I'll write it, sine squared theta plus sine squared theta over 2 sine theta times 1 over cos theta. All right? This is going to equal 2 sine squared. 2 and the 2 will cancel. Sine squared over sine is just sine the top. I should put equal signs, I guess. So this is equal to sine theta times 1 over cosine theta, which is tan theta. Done. Okay, because now we have this is equal to that. And maybe, in case you're not watching the video, I should highlight, okay, well, this is that. And this is probably overkill. Is this? Yeah, and then I'll just circle that. Yeah, this stuff all becomes this. Maybe this over here is this. Too much. Okay. Second one. Sec minus cosec over tan is equal to sine. So again, I'm going to work with this side. And what I'm going to do here is write everything in terms of sine and cosine because there isn't really any identities I'm using except rewriting this as maybe 1 over cosine. Okay? So this is equal to 1 over cos x minus cos x over sine x over cos x. Okay? Now, you guys probably know this, or you should know this, but if you divide by a fraction, it's like multiplying by the flip. And the reason is, and I'll even put this in here, or one of the reasons is, because if we multiply by cos x over cos x, these will cancel, right? So that gives us, I don't want to do that, I want to just get back to blue. This is the same thing as, and I'm going to distribute the cos x. 1 minus cosine squared x over sine x, which is equal to sine squared x over sine x, which is sine x. Done. All right? So now we have sine x and sine x. Okay, last problem from this common review. And I should just mention now, too, you guys are going to have a lot of review to look at. Yeah, work through as much as you can, but be in touch with the teachers if there are any questions, okay? So this question says, if B is acute, and remember, acute means less than 90 degrees, right? So if that's true, and cosine 2b, is negative 7/9, find without a calculator the cosine and the sine. So if b is acute, I like to draw this out. B is somewhere here. Okay, this is angle B. I don't know why I drew an arrow there. Don't need that. So let's complete a triangle here. Right triangle. And cosine of 2b is negative 7/9. Well, how about this? If b is acute, right, and the cosine is negative, that means that b is less than 45 degrees, right? Because if cosine of 2b is negative, you have to be in either quadrant 2 or quadrant 3. You can't be in quadrant 3 because angle b is less than 90. Okay, so I'm going to write in there. I hope that makes sense. I don't know if I explained that well. B is less than 45 degrees since 2b is less than well, completely messed that up. I want greater than, right? B is greater than 45 since 2b's got to be greater than 90. So we know basically that B is between 90 and 45 degrees. Okay, what's the cosine of B and what's the sine of B? So I'm going to write out that the cosine of 2b is equal to, well, we've got some options. Cosine squared B minus sine squared B. Or we can write it as 2 cosine squared B minus 1. Or we can write it as 1 minus 2 sine squared B. Okay, this one doesn't help us because we have two unknowns, right? We can use either of these two because they only have one unknown. All right, I'm going to use this one just because it's the first one I wrote. So we can say negative 7/9 is equal to 2 cosine squared B minus 1. If we move the 1 over, then we know that 2/9 is equal to 2 cosine squared B. If we divide by 2, we know that 1/9 is equal to cosine squared B. So that means that cosine of B can equal plus or minus 1/3, right? Because if you take plus or minus 1/3, you square it, you get a 9th. Okay, we know hopefully we got to take the positive one because of this. B is bigger than 45 but less than 90, right? So it's got to be in quadrant 1. So the cosine B has to be positive 1/3. It's in quadrant 1, not quad 4. And if we know that, well, now we can fill in our triangle. Cosine's adjacent over hypotenuse, so this has got to be root 8. Okay, therefore, sine B equals root 8 over 3. And we'll go with nice green. So these kind of problems are very common, especially in IB. And what you have to do is, take the info that you have, draw a picture, use some logic, because what happens is you get to this scenario and you have to know which one to choose. All right? Okay, guys, that's it. So work through this stuff. Congrats on being very close to finishing the year. And be in touch if and when you have questions. Okay. See you later.